In our last video, we showed you how to simplify the startup and shutdown procedures by installing an inverter with a built-in automatic transfer switch. The inverter we installed also has a low voltage alarm, but it doesn't go off to alert the crew to take action to conserve power, so they find themselves unexpectedly cooking in the dark after only 2 hours of service. It took us a while to figure out what was going on, but these premature shutdowns are being caused by the large initial power draw to start our refrigeration equipment. One of the largest limitations to the technology of lead-acid batteries is that they can only be charged or discharged at a certain rate. If you go over that rate of discharge, say by pulling a lot of amps to start a commercial freezer, then the voltage of the battery bank will appear to drop dramatically. In our case, the voltage of our battery bank appeared to instantaneously drop from 23 volts to 21 volts, which is under the minimum voltage requirement for the inverter to operate, and therefore bypassed the low voltage alarm. Unlike batteries, capacitors can discharge tons of energy in the blink of an eye with little to no voltage drop. In RVs, the solution is to install the capacitors on the equipment itself, but this has its limitations as well because not all equipment can be upgraded. So our solution was to build and install an ultra-capacitor bank that would effectively cover all of the outlets we have in the truck. I purchased 12 of these Maxwell 2.4 volt 3000 farad ultra-capacitors, 12 aluminum straps, and 6 balance boards from China for about $375. When they arrived a few weeks later, I began wiring them together in series to make a 24-volt bank. My wife happened to pop her head out into the garage while I was doing this, and I asked her if she wanted to help me do some soldering. Turns out years of delicately painting her eye makeup on has laid the foundation for an incredible career in soldering. The other end of the wire we just soldered to each of the balance boards will connect to the aluminum strapping on the opposite terminal. You can choose to solder these wires to the strapping, but I've chosen to crimp an eyelet onto the wires and attach them with a screw. After drilling holes in all the aluminum straps and connecting the wires, I began to connect them to the bottom terminals. I think this might have been my 32nd try at getting it so that I did not have these wired incorrectly, so you're going to want to make sure that you're really careful when you do this. After charging everything, I started to test each one of the capacitors, and eventually I ran into one that was dead. I was under the gun to get this finished, so I paid to overnight another capacitor from Mauser and found out that I had ordered one with the wrong terminals. We're learning lessons all over the place here, guys. Believe it or not, I actually did plan for an issue like this to occur, and I purchased one extra capacitor from China. Unfortunately, that capacitor came to me with stripped threads, so I had to fix those if I was going to get this job done. Once I get these threads fixed, I will then be faced with the horrifying task of rewiring this capacitor into an already charged capacitor bank, and I actually do not know how to discharge the ultra-capacitor bank safely, so if anybody has any tips for that, please put them in the comments below. My immediate solution was to use lineman's gloves, which are capable of handling up to 10,000 volts of electricity. As you can see, I managed to not kill myself, so I moved on to the next part of the project, which is to cut and crimp the 4-aught THHN wire. I'm fairly certain that you're not supposed to use bolt cutters to do this, but it's the only tool that I had that was capable of cutting this wire. Since the bolt cutters crimped the wire slightly, I decided to use the vise to round it back out. THHN has a very thick covering on the outside of the copper wire, and I found that a small pipe cutter and a box cutter are the most efficient ways of stripping the wire. Per usual, the connectors that I've purchased do not fit onto the terminals of the inverter, so I have to drill those out on the drill press before putting them onto the stripped off THHN wire. Now moving on to the exciting part of connecting the ultracapacitor to the inverter. You'll see that I've already connected the negative terminal, and I'm currently connecting the positive terminal to the ultracapacitor. I am later going to be connecting the battery bank to the positive and negative terminals of the ultracapacitor. So the ultracapacitor is effectively sitting between the battery bank and the inverter. Alright, so our balance boards, you can see the lights are lighting up on several of them to keep things from being overvolted, as these last two begin to take on the load from the battery bank. So the battery bank is connected to, there's the negative terminal, and then here's the positive terminal coming from the battery bank, and that goes through all of these boards and all these capacitors back to this 4-aught connector, which then connects to the inverter. And there we go. AC power from the wall is off. We are running on nothing but battery power. Showing battery voltage 25.4 volts. This is a screenshot of the freezer kicking on in the food truck, and as you can see, the output load is at 119% and the battery voltage is remaining at 24.8 volts. As you'll recall, when I started this video, this used to drop all the way down to 21 volts and cause the entire system to shut off. Freezer just kicked on, and it barely moved the battery voltage. 0.4 volts. That is amazing. With a successful test under my belt, it was time to start with the final install. If you've never worked with 4-aught THHN wire before, I recommend not going to the gym for a few days before you go and try and start bending these cables around. It is quite difficult. Once I was done with my workout, you can see that the cable wiring is the same as it was earlier. It's just a little bit more compact, and that is a switching power supply that I've added for the 2 fans that we've got running to move the 400 CFM worth of air to keep everything cool, even on the hottest days. The wiring that I've done in this video is a perfect example of how to work with an inverter that has a separate charger that you can wire directly to the battery bank. But as you'll recall, the inverter that we purchased is actually a inverter/charger. So, in my next video, I'm going to show you how to adjust the wiring and add a switch to accommodate an inverter/charger. Thanks for watching, and if you'd like to see more videos like this, please subscribe. Thank you.